In this model, we have discussed the various standard distributions, both discrete type as well as the continuous type in last two lectures. That is, in the first lecture, we have discussed various discrete type common distributions, starting from constant random variable, then Bernoulli distribution, then binomial distribution, geometric distribution, then discrete uniform distribution, then we discuss the Poisson distribution. So, these are all the standard discrete type distribution which we have discussed in the lecture 1. In the lecture 2, we have discussed standard or common distributions of continuous type random variables. In that lecture, we have discussed continuous uniform distribution between the intervals. Then we discussed exponential distribution. Then we discussed the gamma distribution, beta distribution, Cauchy distribution, and we have given some list of distributions. In particular, we have discussed the normal distribution. That's a very important distributions of continuous type random variable, which is a common distribution. So, we have discussed normal distribution also. From the normal distribution, how one can get the standard normal distribution. Then we have solved one or two problems in the normal distributions also. Now, in this lecture, we are going to give a few problems. Then one can identify what is the correct distribution attached with those problems. Then using those common distributions, one can get the solution. That means we are going to use these common distributions to get the solution of the given problem. The first problem is a fair die is rolled 5 consecutive times. Let x be the random variable representing the number of times that number 5 was obtained. The question is, find the probability mass function of the random variable x. Here the fair die means it is unbiased. That means the probability of occurrence of each possible outcomes are same, and since there are 6 possibilities, therefore the probability of each possible outcome is going to be 1 by 6. So, a fair die is rolled 5 consecutive times, therefore the probability of each possible outcome, that is equal to 1 by 6 when I takes a value 1, 2, 3, 4, 5 and 6. So, this is going to be the collection of all possible outcomes, and the probability is going to be 1 by 6 because it is a fair die. Is rolled consecutively 5 times. So, now the random variable x is defined from omega to r, where omega is a collection of all possible outcomes based on this random experiment. That random experiment is a fair die is rolled 5 consecutive times. Therefore, let x be the random variable representing the number of times the number 5 was obtained. So, you can make a event A, that is nothing but the number 5 was obtained. The event A is the number 5 is obtained. The probability of event A is going to be 1 by 6. So, that can be treated as the probability of success for each roll. Like that, we are making 5 independent rolls. That means the probability of success is 1 by 6 and the probability of failure is 5 by 6 in each Bernoulli trial. Here, when I say Bernoulli trial, getting the number 5 with the probability 1 by 6, that is going to be the probability of success, and the probability of a failure is not getting the number 5, that is with the probability 5 by 6. So, therefore, each Bernoulli trial with the probability p, that is 1 by 6, and the failure probability is 5 by 6. Like that, we have n independent Bernoulli trials. Here n is going to be 5. So, the random variable says representing the number of times the number 5 was obtained. That means it is same as 5 independent Bernoulli trials and the x represents the total number of n independent Bernoulli trials gives the values. Therefore, we can conclude x follows binomial distribution with the parameters n comma p. Here n is 5 and p is 1 by 6. In this problem, the x follows a binomial distribution with the parameters n and p, where n is 5 because 5 consecutive times we are rolling the dice, all are independent, and the probability of success in each roll getting the number 5, that is 1 by 6. Now the question is find the probability mass function of x. You know that since it is a binomial distribution, immediately you can write the probability mass function is of the form ncx p power x 1 minus p power n minus x, where x takes a value 0, 1 and so on till n 0 otherwise. This is a probability mass function of binomial distribution. So in this problem, this is going to be 5cx 1 by 6 power x 5 by 6 power 5 minus x when x takes a value 0, 1 and so on till 5, 0 otherwise. In this problem, I have stopped it finding the probability mass function. Once you know the probability mass function, suppose you want to find out the probability of x is less than or equal to 3, or if you want to find out the probability of x is greater than 4. So all those things is nothing but the probability of some events. So once you know the probability mass function, you can get the probabilities. Suppose the question is find the mean, variance, because since it is a binomial distribution, you can use the relation of mean and variance and so on, and even you can find the further moments for this problem. Now we will move into the second problem. The second problem is the number of patients who come daily to the emergency room of a certain hospital has a Poisson distribution with the mean 10. What is the probability that during a normal day, the number of patients admitted in the emergency room of the hospital will be less than or equal to 3? This is a very typical situation in which the number of people or number of customers or number of units entering into the system, any system, sometimes we can make the assumption of Poisson distribution because it comes in a very rare event and the possible values are 0, 1, 2 and so on, countably infinite. In that case, it's good to make the assumption of that follows a Poisson distribution. So therefore, in this problem, it is already made the assumption it follows a Poisson distribution with the mean 10. So the question is, what is the probability that the number of patients entering into the hospital will be less than or equal to 3? Since already made the assumption of it follows a Poisson distribution, so the question is immediately you can make out, you can create a random variable x is nothing but number of patients who come daily to the emergency room. Since we made already the assumption x follows a Poisson distribution with the mean 10, usually we write the parameter. If you recall the Poisson distribution, suppose the Poisson distribution has the parameter lambda, the mean is all lambda, even the variance is also going to be lambda. So here the information is given the Poisson distribution with the mean 10, that means it is lambda is 10. Therefore, you can immediately write down the probability mass function of the Poisson distribution, that is e power minus lambda, lambda power x by x factorial when x takes a value 0, 1, 2 and so on, otherwise 0. So this is a probability mass function. So in this problem, lambda is 10. Therefore, this is e power minus 10 10 power x by x factorial when x takes a value 0, 1, so on, otherwise 0. So the question is, what is the probability that during a normal day the number of patients admitted in the emergency room of the hospital will be less than or equal to 3. That means you have to convert the given problem into the form of that is x less than or equal to 3. This is a required probability. This is same as summation of probability of x takes a value small x when small x is going to be less than or equal to 3. That means it is a probability of x is equal to 0 plus probability of x equal to 1, probability of x equal to 2 plus probability of x equal to 3. You substitute x is equal to 0, 1, 2, 3 and get the probability mass at those, add all the values. If you simplify, you will get the answer. It is 1.0336 into 10 power minus 2. Even this problem can be asked in find out the probability that no customer or no patient admitted in a normal day. That means that is same as probability of x equal to 0. Or you can ask what is the probability that always some patients admitted in the emergency room in a normal day. That means that is 1 minus of probability of x equal to 0. Or there is a possibility of question, what is the variance of x? Since you know the Poisson distribution, the mean and variance are same, the variance is also going to be 10. So like that many more problems can be created once the situation is given and some information is provided. You can find other measures in a nice way. We will move into the third problem. The third problem is there are 135 students inside a conference hall. The probability that one of the students celebrates his or her birthday today equals 1 divided by 365. What is the probability that 2 or more students from the conference hall are celebrating their birthdays today? In this problem, we made the some assumption the year is not a leap year. Therefore, we made the probability that the one of the students celebrate his or her birthday today equals to 1 divided by 365. That means we made the assumption the year has 365 days. The question is, what is the probability that 2 or more students from the conference hall celebrating their birthday today? 2 or more, that is equivalent of saying negation in the form of 1 minus no and 1. That means the probability that 2 or more students from the conference hall celebrating their birthday today, that is same as 1 minus probability that no one is celebrating minus only one person celebrating, because the summation of all the probabilities is 1. So this question either you can solve it what's the probability that 2 people having a birthday today and 3, 4 and so on, add all the values, or you can go for 1 minus of no one celebrating minus only one person celebrating. So let us find out the probability. The clue is there are 135 students and the probability of success is 1 divided by 35. Suppose I make it n is equal to 135 and p is equal to 1 divided by 365. I can match this problem with the number of students celebrating the birthday, that is number of students celebrating their birthdays, that is going to be capital X. Then I can conclude x follows a binomial distribution with the parameters n comma p, where n is 135 and p is 1 divided by 365. By doing this, I can get the probability of x is greater than or equal to 2 by applying the binomial distribution probability mass function and so on. Here we should observe the n 135 and small p is n is sort of very large and p is almost close to 0. Even though we say the p is open interval 0 to 1, here the p, the probability of success, that is very small. Therefore, it is good to do by approximating this binomial distribution with the Poisson distribution. That is x follows Poisson distribution with the parameter lambda. Now the question is, what is lambda? Where lambda is n into p. That means you multiply 135 with 1 divided by 365, that is going to be the lambda value. So, one can simplify and get the value lambda. So, if you do the simplification, that lambda is going to be 27 divided by 73. So, once you get the lambda, that is a parameter for the Poisson distribution. That means you know the probability mass function of the Poisson distribution. Therefore, the required probability is the probability that 2 or more students from the conference hall are celebrating their birthday today. That is nothing but x is greater than or equal to 2. That is same as either one way find out the probability of x equal to 2, probability of x equal to 3 and so on, sum it up, or the other way is 1 minus probability of x is equal to 0 and probability of x equal to 1. So, this is easier than finding out the other side, because the summation of probability is 1, therefore, this is same as this. So, you can get a probability of x equal to 0 because you know the probability mass function. So, that is 1 minus probability of mass function for the Poisson is e power minus lambda, lambda power x is 0 here divided by 0 factorial. So, it is going to be e power minus 27 by 73. When you substitute the probability of x equal to 1, you will get 27 divided by 73 times e power minus 27 by 73. If you simplify, you will get the answer, that is 5.3659 times 10 power minus 2. So, this is the easy problem. You can create many more problems with the same first two statements. Since the n is large and p is almost 0, we are going for binomial to the Poisson distribution.